Okay, today we're going to talk about the lasso method for finding an equivalent fraction. Let's go ahead and look at our model right here and figure out what this fraction is first of all. I know that I need to count the total number of parts, and that will be my denominator. And I see 1, 2, 3, 4, 5, 10, 15. 15 total parts. And my number of parts shaded is 1, 2, 3, 4, 5. 5 parts shaded. Now let's say I want to find an equivalent fraction for this, and I don't really know where to go. One thing that you can do is lasso like sections. So if I have 5 sections that are shaded, I could lasso those together to see if I can make complete sections of 5. So let me show you what I mean. Okay, if I go like this, I have one set of 5. I can get another set of 5 and another set of 5. Now notice how in this first set they are all red. That's good. I can't have one of the red ones in a different set. Each set has to have the same color in it. No mixing up in the sets. So what I have now is I kind of ignore my green lines. And I look and I see how many sets I have. I have 1, 2, 3 sets. So those 3 sets would be my denominator. Then I just ask myself, how many of those 3 sets are shaded? And again, I'm looking at the complete set, not the 5 there. That wouldn't be right. So I have 1 set shaded. So the answer for an equivalent fraction would be 1/3. And we call this lassoing. So you see that 1, 2, 3 parts and 1 part is shaded. Or I can say I have 15 parts and 5 are shaded. Those are both the same fraction. And I can tell that because I know that if I take 1 and multiply it by 5, I get 5. If I take 3 and multiply it by 5, I get 15. So that is one example of the lasso method. Let's try another one. We're going to start with this guy right here. Let's take a look and see what we have for a regular fraction first of all, and then we can figure out if there's an equivalent fraction or maybe more than one equivalent fraction to go with it. So I'm going to count my total number of parts. I have 1, 2, 3, 4, 5, 6 in each column, so that'd be 6, 12, 18. My total number of parts is 18. The number of parts that I have shaded is 2, 4, 6. I see 6. So counting by ones, I see that I have 18 boxes in all and 6 are shaded. Now to use the lasso method, we're going to try to put like parts together. And we've already done the ones, so let's see if we can figure out if we can put things in groups of 2. Well, since 2 is both a factor of 6 and 18, I will be able to put groups of 2 on here. So I'm going to start by circling these red ones up here. 1, 2, 3 groups of 2. Now here these have nothing in them, but I still have to count them. So 4, 5, 6, 7, 8, 9 groups of 2. So now I have, instead of having 18 boxes, I need to look at this as though I have 9 groups. So I'm going to put a 9 down. That's my denominator. And I need to figure out my numerator. So I'm going to look back up at my red and figure out how many of the groups are shaded. How many lassoed parts are shaded? 1, 2, 3. I don't count 6 because I have to count the whole group as being shaded. So that would be 3 parts shaded. This tells us then that 6/18 is equal to 3/9. Now some of you might be looking at this and saying, oh, Miss Barrow, you can do it this way or you can do it that way, and you are correct. So let's see how else we can do it. See what other factors are the same between 6 and 18. Well, I like going in order, so 1 was taken care of. This was my 1s. This was counting 2s, groups of 2. Will 3 work? Well, 3 is a factor of 6. 3 is a factor of 18. So yes, 3 will work. So I'm going to write my 3 here. And let's see how many groups of 3 we can make. That's easy. We're going to go crosswise so it doesn't get too difficult to see. And I'm going to make my pen a little bigger so it shows up. So here's 1 group of 3, 2 groups of 3, 3 groups of 3, 4 groups, 5 groups, 6 groups. So how many groups did I make? Easy. I made 6. Sometimes it helps to just count right as you go. 6 groups of 3. And how many of my groups of 3 are shaded? Okay, if you said 6, that's not right because we're not thinking of them as little parts anymore. So it would be 2. See, 2 groups have shading, 4 groups don't. So 2 6. So now I see here that 6/18 is the same as 3/9, which is the same as 2 6. Now, is there anything else that we can count by to group up here? Are there any other factors of 6 and 18 that are common? Well, we've done the 3. 4 doesn't work. 5 doesn't work. Does 6 work? Yes, 6 is a factor of 6, and 6 is a factor of 18. So let's choose another pen color. See if yellow will show up for us. And we're going to circle groups of 6 and see what we come up with. 1, 2, 3. Now, some people might be wondering, why didn't I go up and down? Because there were 6 in each column. I didn't go up and down because that would leave 2 different colors in my groups, both red and white, and I can't do that. This way, I have the same color in each group. All right, so how many groups did I make? I made 3 groups. And how many groups were shaded? 1. And that was counting by 6s. So I know that 6/18 is equal to 3/9 is equal to 2 6 is equal to 1/3. All from using the lasso method. You can call it circle if you want. I like to call it lasso method, but that's it. That's what we have. 4 different equivalent fractions off of 1 rectangle. Good job.